Okay, so this video is going to cover unit or lesson 9.1, which is going to cover the introduction to quadratic functions. We're going to start off in your green packet on page 2 with a little review of the other two function families that we've talked about so far. And so the first one we talked about way back in trimester 2 was the linear function. And that was our equation that went y equals mx plus b. At least that was the most common way we talked about it. And so as with all functions, the x and the y are points on the graph. The x is your input. The y is your output. And when we graph all those inputs and outputs, we get a graph. M was our slope, which we could think of as the rise over run. And B was our y-intercept, which we often thought of as our starting point. So what I want you to do here is go ahead and try these examples. Pause the video. On here, you're going to be finding the slope from the graph, the y-intercept from the graph, and writing the equation. Here, the x-intercept, the y-intercept, and the slope. And then here, see if you can remember how to find the equation of a vertical line and a horizontal line. So pause the video for a little while, try those out, see what you remember, and then we'll go over them. Okay, so in this one, finding the slope, I'm going to start at one point, do my rise and my run, and I went up 3 over 1, so my slope would be 3. My y-intercept is the point where I cross the y-axis, so that would be the point 0, -4, and -4 is my b. And so my equation, y equals 3x minus 4. Over on example 2, the x-intercept is the point where we cross the x-axis, so that would be the point 3, 0. The y-intercept is where we cross the y-axis, so that would be the point 0, 2. And then the slope, we can do our rise and our run. So I went down 2 over 3. So -2 over 3 is my slope. And then these last ones here, vertical lines are always x equals equations. So x equals -2 in this case, because all of those points have x coordinates of -2. And horizontal lines are always y equals number. So in this case, all of our y coordinates are 2. So y equals 2 is our equation of that horizontal line. Okay. The next equation we talked about, the next function family we talked about was the exponential function. This is the one we just did. Basically, last week, we took a test on it last week. So y equals a times b to the x. And as before, x comma y is just a point on the graph. A is our starting point. And then the b value is telling us how our equation is changing. So if b is greater than 1, our equation is getting bigger, it's growing. If b is less than 1, our equation, our function is getting smaller, we'd say it's decaying. So on these examples, we're just going to identify what is a, what is b, and then answer a couple of questions about them. So here, a is our 3. That means the y-intercept here is at the point 0, 3. B is 2, which means it is growth. And our asymptote is this line right here, the x-axis, which is the equation y equals 0. On this one, a is not shown here. It's that hidden 1, which means our y-intercept is 0, 1. B is 1/2, which means it is a decay. And our asymptote is still the exact same line. It's the x-intercept. So y equals 0. Okay, so at this point, that's what we've talked about basically the last few months. We've spent a lot of time on linear functions, a little bit of time on exponential functions. And now we're going to talk about our last function that we're going to be basically working with until the end of the year. So just as a first example here, we've got y equals x squared. And I'm going to start here at 0 in the middle. So when I take 0 for x, that means I'm plugging in 0 for x, and I'm seeing what I'm going to get for y. 0 squared means I'm taking 0 times 0, which is 0. And so my x comma y is 0, 0. When I plug in 1, 1 squared means I'm taking 1 times 1, and 1 times 1 is 1. So I get the point 1 comma 1. They get more interesting, I promise. 2. I'm going to plug in 2. 2 squared means I'm taking 2 times 2, which is 4. So I get the point 2 comma 4. And when I plug in 3, 3 squared means to take 3 times 3, which is 9. So my x, 3, my y, 9. 3 comma 9 is my point. So I did all those positive ones first. The negative ones we have to be just careful of. When I plug in negative 3, that means I'm taking negative 3 times negative 3, which is a positive 9. So I actually get the coordinate negative 3, positive 9. And the same thing is going to happen. When I do negative 2 squared is positive 4. So negative 2, 4 is my point. And negative 1 squared is positive 1. So negative 1, positive 1 is my point. And we just graphed 7 points there, but every single point in between is also one of these. So we'll go ahead and connect the dots here. And we've got a graph that looks a little bit like that. So that's what y equals x squared looks like. Feel free to pause the video if you need to fill any of that out. But we just plugged in x's to our equation, got out y's, graphed our function. For the next 3, we are going to make Desmos do the hard work here. So you can see these. I'm going to go ahead and show you how to type these into Desmos. So if I open up Desmos, I've actually got them all typed in here already. So y equals x squared plus 1. If I graph that, you can see it looks like that. If you click on a point on the graph, like an important point, like here, this is the y-intercept, 0, comma 1, it'll show you that coordinate. So I'm going to make sure I plot and label all the intercepts here. So 0, comma 1 is my y-intercept. And I'm going to try to find a couple of more points here. So it looks like maybe 1, 2, and negative 1, 2, and maybe 2, 5, and negative 2, 5. So I'll plot those points. 1, 2, 2, 5, negative 1, 2, negative 2, 5. Just to give me a few more points to go off of here. But I'm just going to make sure I've actually labeled the intercepts. So the x-intercepts, the y-intercepts are going to be key ones. So if I go to this next one here, and again, feel free to pause. I'm going through this quick so the video is not forever long. My graph looks something like this. You can see here I've got 2 x-intercepts, negative 4, 0, and 2, 0. So I'll plot those. I've got a y-intercept up here at 0, 8. And the other key point that I can go ahead and graph is this highest point here, since it'll tell me that, negative 1, 9. So I'll plot that point. And I'll go ahead and just label these intercepts since it does ask me to do that. And then I'll do my best to just sketch the graph, but if we have those key points, that's good enough. So something like that. And then for my last one, I'll go ahead and turn this off. Again, I've got some key points here, 0, 0, 2, 0, 1, negative 2. I'll make sure I plot those on there. So 0, 0, 1, negative 2, 2, 0. I'll label my intercepts. And then my graph is going to look something like this. So you can see Desmos can do that pretty quickly. If you want to try to find another point here, looks like negative 1, 6, and 3, 3, 6 are some other good points you can label on that one. So at this point, what we want to kind of think about here is, what do those all have in common? So if I think about the equations, all of them had an x squared in it. They were all some sort of y equals x squared equation. Some extra stuff, but that's the basics. The shape they all have in common is that U shape. They either do this kind of up thing, we'll refer to these as up, or they go down. Think about what each end of the graph does. But they all look kind of like that U shape. And so this family of graphs are called quadratic functions. And the general form of a quadratic function is going to be y equals ax squared plus bx plus c. And hopefully you've noticed here, the only thing they have to be quadratic is that x squared term. Not all of them had a bx, not all of them had a c. The first one only had x squared. It was still quadratic. So the y and the x are still the same thing, point on the graph. A, B, and C we will come back and talk about much more later. A is the coefficient on x squared. B is the coefficient on x. C is the constant. And some things that we'll talk about here. A might not be written. If A is 1, like 1x squared, we don't write it. B could be 1. If we just had plus x, that'd be 1x. But if we didn't have any x term at all, we would say B is 0. 0x, we wouldn't write x at all. And also C could be 0. And if we didn't have a plus a number or minus a number, C would just be 0. And that's okay. The last thing here is the shape. This shape we call a parabola. So we'll have to practice how to say parabola several times here. But a parabola is the mathematical name for this U shape. And parabolas are really useful in a lot of different things. If you ever look at a satellite dish or a magnifying glass, it's a parabola. Those shapes are really good at focusing sound and light, things like that. So we use them a lot in real life. Parabola is the name of that shape. So I'm going to go ahead and turn this video off. Your next job here is to do this practice on all these. These last ones on the very last page, you are just plotting them on Desmos. Again, clearly label the x-intercept. So there's always going to be at least one y-intercept, 1 or 2 or maybe none x-intercepts. Tell them what A, B, and C are, and then draw that graph as neatly as possible. Okay.